So once the internet's connected, once I have all of my switches and routers and everything plugged in, then my two computers can communicate information. Now, when I say computers, really it's software that's communicating. It's things that we're writing as software developers that allow us to communicate between the computers. Computers don't do anything. It's the software that runs on them that does stuff. And the important thing is to have a standardized way of sending messages back and forth. As we said before, when we plug two things together, it's ones and zeros. And many devices for a long time defined their own protocol of what those ones and zeros means. I worked on some of that a long time ago in embedded systems. I worked on the serial port, the thing you plug in, for GPS receiver devices that would communicate with other software to allow you to get your position or set up the device or whatever you want to do. Well, for the internet, there's some standard messaging protocols, and that's the TCP part of what maybe you've heard of TCP/IP. So the transmission control protocol for the internet protocol that's on there. I mean, so that's one version. There's also something called UDP. So there's TCP/IP and UDP/IP. The main difference here is TCP is point-to-point communication. UDP is typically a broadcast communication where I send it to a bunch of folks. It's not terribly common to be used, but it is very useful in some situations. So, for example, when I worked on the first flight certified Ethernet, many years ago on the Boeing 767-400. This is the first time we used Ethernet on an airplane. We used UDP protocol to be able to send data from the back of the airplane, essentially the systems that was collecting all the information about the real-time status of the airplane, up into the screens that the pilots see, because there's 6 screens and there's multiple back-end systems that are redundant, that they allow for failure, and so you never want one part. They'll be the only working part on an airplane. You want at least two. Well, this system basically allowed you to send, which is essentially the same data to 6 screens that you would send to one, and not have to do it 6 different times. So that was one example of where that would be used. But this protocol essentially takes care of a lot of the plumbing of how do I route a message, how do I get a message out there. The design of TCP is basically taking it from one IP address to another IP address. That's what the IP helps with. But then it also allows it to be confirming that the message was received. It's called an ACK protocol, acknowledgement, ACK, acknowledgement. Um, and that way your data was received and was there successfully. Um, and then it also there's a certain amount of error detection along the way. There's this notion called a checksum, which is a mathematical formula which hopefully helps you detect if some bits changed in transmit. That's always a risk when you're going through hardware systems, particularly if your wireless system, certainly that's a risk. You can have electromagnetic interference, but even to some degree, you can have just degradation of lines or North Pole solar effects or any number of things that could happen to corrupt bits along the way. And so TCP is there to try and help detect and correct errors to some degree as well. Now, when we send data from an application, what happens is our data gets wrapped up essentially in a TCP wrapper, and that is then wrapped in an IP envelope. And thankfully, we don't have to worry about the TCP IP layer in most programming language. Somebody has coded that, they've taken care of that for us. All we really need to do is come up with some data and send that. And that's the trick is you have to figure out what that data inside the application looks like. There's a ton of custom implementations that you can send here. When we saw that protocol before, where you normally see HTTP or HTTPS : / that typically is the descriptor of what's inside the message. So the most common is HTTP or HTTPS, which is the websites, HTML, as we'll talk about in a little bit. But there's other protocols. So if you're a Java programmer, there's something called JDBC : / which is sending information back and forth to databases. There's all sorts of protocols, and you can define your own that allow you to define what the data inside of it looks like. But for the most part, we have some very typical formats that we use to pass data on the internet. Um, HTML is the most common. That's the top left picture here, HTML. But then there's also this notion of JSON, JavaScript object notation, which is a way of not just putting text and user readable stuff, but actual data. We use cascading style sheets to format HTML. We'll talk about those a little bit as well. But then there's also the notion of web services. So web services primarily use XML, which HTML is a type of XML, but it's a customized format for you to be able to send data from one computer to another. Um, Most of the internet protocols these days send data as text, some sort of ASCII or ISO encoded text that uses some sort of readable format because it's much easier to debug and process and it's much more dynamic. In high performance situations, you still might send things as ones and zeros. You actually send real numbers, and send compressed data, but only when performance is a real big issue. I want to minimize the amount of bandwidth I'm using to send the data, or I want to be able to process that data very fast. That comes at a cost, though, the cost being development time. The more specific, the faster a data message is, the more time somebody has to spend writing the code for that, which is why, for the most part, we're okay using the rather inefficient XML or HTML way of sending data because it's okay because we have so much bandwidth in the internet for the most part that we can send that data and not have to worry about it. But this gets into the notion of how internet systems change up our programming paradigm. For the most part, you've probably written applications where your program directly interacts with the user. Well, now your program either is interacting with the user and sending user data to another computer, or it's receiving requests and communication from another computer and may never talk to a user whatsoever. And this gets into the idea of client-server applications. Client applications typically are user facing, but they're not required to be. A client application might simply be a system that reads files and sends it to a database, for example. But in this web example here, we're talking about HTML, CSS, JavaScript, all those sorts of things that would be running into a program called a browser. Somebody coded the browser you use today, whether it's Google Chrome or Microsoft's Edge or Mozilla Firefox or Apple's Safari. Somebody coded that. That is an application, or somebody wrote code in that. It's code that automatically displays and processes HTML, CSS, JavaScript, things like that for us. But we can write our own client applications as well. We could have a little graphical user interface. We could have a command line interface. It doesn't matter. But our application on the client side then would create messages to send over the internet. And then a server application on the other side receives those messages and does something with them. And so in a web server application, this picture, this free picture from PowerPoint shows PHP, but it could be Python, it could be Java, it could be C Sharp, and then some database, and that typically is running on what's called a web server, such as Apache. And so we can create software that runs on an existing server, like a web server, and that is both a hardware and software sense of the server, or we can write our own server application. We could write code from scratch that listens to and receives communications over the internet and does something with that. And so for the most part these days, we leverage existing quote unquote server solutions. And that means software servers that we can kind of just write a little micro application that sits on top of it. And we all have all of the internet level stuff taken care of for us. We just basically write a function that responds to some query. And that's amazing these days. It makes it really, really efficient. But know that all this stuff builds on some of the very basic foundational stuff we're going to look at as far as the programming language and how it accesses the internet. And so that's our next stop is let's dive in a little bit further and talk about how our programming language can access the internet.